On this episode, Scott and I welcome Allan Friedman, Senior Advisor and Strategist for CISA, to discuss, of course, SBOMs and the supply chain. Stay tuned.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
Below the Surface, the firmware and supply chain podcast from Eclipsium in collaboration with the Cyber Risk Alliance. It is episode number 22. Mr. Scott Schefferman is here with us. Scott, welcome.
Thanks for having me, Paul. Super excited about today's guest. It's been a while since I've seen you in person, Allan, but this is a great opportunity to catch up and talk all things SBOM.
I know. I can't wait. Before we get into it, though, Below the Surface listeners can learn more about Eclipsium by visiting eclipsium.com/go. You can find the ultimate guide to supply chain security, which is an on-demand webinar, and unraveling digital supply chain threats and risk, a paper on the relationship between ransomware and the supply chain, and a customer case study with DigitalOcean. All that and more at eclipsium.com/go. Dr. Allan Friedman is a senior advisor and strategist at the Cybersecurity and Infrastructure Security Agency. Wow, that is the fanciest introduction for what I would term is also in my notes as the father of the SBOM, which is just hilarious when we put it that way, Allan. Allan also likes cocktails and food and cooking. And so, Allan, welcome to Below the Surface.
Thanks so much. Happy to be here again.
I didn't want to go through the formalities, right? Because Allan, but we haven't chatted on a podcast for quite some time. Like I feel like years ago, we're like, what is this SBOM thing? This guy Allan is doing it and is really excited about it. And so when you're presented as like the father of the SBOM, I'm like, were you like in a lab or like somewhere and was like, we need, what we need? We need this, it's almost like a manifest or some kind of log, or it's a bill of material. It's a software bill of material. Like it was all you that created was it all you? I don't know.
It was very clearly not my idea. Okay. People have been talking about it for a while, right? You go to the DevOps crew that was pulling from, Gene was inspired by industry. I've always loved that. Right. Like a lot of our ideas about modern software, we actually pulled from heavy industry.
Yep.
And then folks like Josh Corman and Jeff Williams were involved in it. So it'd been around for a while. I just was the guy who wouldn't shut up about it. And I happened to work for the US government, which meant that I could actually draw a little attention to it. And it was also right place, right time, where there was a realization that we had a lot of software that we needed to better manage. And then the last thing that sort of slotted in was we had a couple of crises where it was really obvious that we needed to spend more time talking about what was in our software. And I think that's how it finally went from sort of this niche idea to something that everyone is now paying attention to or cursing my name because they have to do a compliance exercise, depending on your perspective.
Sure. But you were passionate about it because of like current events. Right place, right time, right? Like it was a perfect storm. You were like, I'm the person. I'm the one who's going to be passionate.
And it's bananas that we don't have this. Like it just when I talk about this to non-security people and non-tech people, they're just sort of really surprised. Like, wait, we don't have this already? Every time I go to the store and I buy food, there's a list of ingredients. You're telling me the things that the Navy buys or the things that the power plant near me buys don't have this same level of visibility. And so that's a lot of it was just, how is it possible we don't have this? And then discovering it was a really fun problem.
Yeah. Well, because I think it's very unique from other bills of materials or ingredients list. And while they do share similarities, right? When it comes down to software, though, there's a lot of sharp differences in the way that's presented because the software will change. Once I package something up, put ingredients list on it on the shelf, and it's not changing. Yes, environmental, like it could go change on its own, but I'm not changing anything. When software though, I'm pushing out new releases and that software is changing. How do we deal with that first aspect of the supply chain in SBOMs, Allan?
So that part is actually not super hard, which is just as you change your software, there are other things that you have to track. And so we just add this to the challenge of version management and asset management, things like that. But I'll also tell you, I've spent a lot of time learning about some of the history of different other types of lifts ingredients. And it turns out it was something that is colloquially called the peanut butter wars, where people actually spent a decade or more trying to figure out how much of something is peanut butter. So even some of the definitions that we're bumping into in software, what do I call this? Is if I backport, is it the same version?
Right.
These aren't unique to the software. We do need to come up with software-based solutions, but people have been fighting about very almost philosophical questions of what does it mean to say that something's made of something else for a while.
Yeah, because we do think we're unique in the fact that backporting, right, is this, yes, I have this ingredient, but is it really that ingredient, or is it a different ingredient, and how much similarity or difference does it have to another ingredient that may have a different name, but they are in fact the same, right? That's one of the things we're working on, is how do we compare components. How important is that to you, Allan, about the uniqueness and or similarity of various components that may be identified in an SBOM?
So probably the biggest problem that everyone will bump into when they start thinking about SBOM is not even, is this component similar to another component? It's, what is this component called? Naming or identity is one of these things that just keeps popping up in every aspect of security once you start caring about data. You care about the data of what's in software, whether it's just vulnerability management or, a deep composition analysis. What is this thing even called? And identity is a huge challenge in all of IT. I would say in the entire 40-year history of IT, we have successfully built one global, decentralized, distributed, and robust namespace. And the annual budget of ICANN, which runs DNS, is about $100 million. No one has yet given me that kind of budget. And so we bump into some very common issues, such as, is this Windows _7 or Windows -7? Is version 1.2.3a before or after version 1.2.3? So these are problems that we're not going to solve through unilateral government action, but we're trying to get some headway on them. And to do a quick plug for some work that we've done here at CISA, we just issued a white paper on software identity saying software identity is hard. Here are some of the solutions. And many of your listeners will be familiar with things like CPE and package URLs or PURLs. But there aren't any easy answers. So that's even before we start to get into product comparison, we want to say, well, what is that thing?
Yeah. And I have an example for you. I don't want to pick on Zixel. I think it's actually pronounced Zicel, but I hate saying Zicel. I like saying Zixel better because it's easier. So, but Zixel had a series of vulnerabilities, in fact. And again, I'm using them as an example. I don't want to seem like I'm picking on them. They did fix these vulnerabilities that I speak of, right? But the vulnerability was leveraged in an attack against critical infrastructure in Denmark, right? And the component that has had a few different vulnerabilities in Zixel firewalls has to do with the IPsec VPN implementation. Now, I started digging into this, and when I did, I discovered that this particular piece of software, I'm like, probably not developed by Zixel themselves, right? If I'm going to go get an IPsec stack implementation, I'm going to license it from someone else, right, who's already written it. And I traced it back, Allan, and it was like 3 or 4 company acquisitions behind to your naming point. The name of the software had changed. Names of the companies that were involved in the software had changed due to several different acquisitions. And I was like, is this the next vulnerability came out in this particular component, and they called it out as a QuickSec IPsec vulnerability. The initial one, they didn't. I'm like, this impacts CPE because is this vulnerability only in Zixel firewalls, or is it in QuickSec? And who else has QuickSec? If we can't name the component and trace the component back, I mean, this is the problem that we're speaking of, right? That SBOMs hopefully can solve, but we still have the issue.
And that's right. That's exactly why we need this. And will it be perfect immediately?
No.
Nothing in security is perfect. But this is why you need this kind of visibility. And what happens when you don't have visibility is where things get trickier, because once you have the data, we can always work on tool vendors who can say, okay, these two things are the same. You use fuzzy matching.
Yeah.
There are ways around it. It may not always be open source, but a world without SBOMs is just super messy. My favorite example is, it's now getting a little dated, the Ripple 20 vulnerability, which is one of those branded things. It was a flaw in the Trek TCP library, which was widely used in IoT devices and in OT devices. So
that was Forescout's research, correct?
It was Forescout, and it was a company. Oh my goodness, I've forgotten the name of the. They worked with an Israeli research company, JSOF.
Okay.
That partnered with Forescout to find it, and what the Forescout team had to do, because they wanted, right? We talked about, hey, we don't pick on companies when we point out their vulnerabilities, because everyone has vulnerabilities. The important thing is, what do you do once you know about a vulnerability? That's a big part of what we do here at CISA. But the JSOF team went on LinkedIn and did a power search looking for anyone who claimed experience dealing with the Trek IP library, looked at where they worked, and that's how they reached out to people to do that kind of disclosure.
Right, because this was a TCP/IP. It was a TCP/IP stack vulnerability, but the TCP/IP stack had been developed by a company and then licensed to other companies. And so it was mostly in embedded systems and IoT gear. So if you had experience working with that meant your company licensed it. It also meant you were vulnerable, right?
Exactly. And that's where we want that kind of visibility to sort of not have to do that every time there's a new vulnerability.
Yeah, I mean, using LinkedIn to find where the software is vulnerable, probably not the best option.
Yeah.
Allan, what's your take on the kind of the pushback you get from some of these vendors that, hey, the SBOM is effectively our intellectual property, and that's our competitive advantage, and this is a highly competitive, low cost, hyper velocity, feature velocity environment. Are they changing their tune at all, or are you still getting pushback there?
We always get pushback, especially when we're the government and we're proposing that people change how they do things. Right, you'll get the trade associations and the lobbyists in DC will be fighting a rearguard effort, even as the senior engineers in the company are like, "Oh yeah, we should implement this. This is important." So one of the larger software vendors in the world, Shipped Enterprise Software, basically publicly said at a meeting, "Hey, 10 years ago, the security flaws we were fixing were from our engineers. Today, all the flaws we're fixing are from upstream, right? Because everyone's building their thing on open source. So these organizations need it internally." So that's a big part of our point, is to say, hey, first, do you have this stuff internally? And if you don't, everyone should be asking why not, right? If you want to buy software or use software, and someone can't claim that we have an accurate, up-to-date, and complete SBOM, then you should be asking why not. And there's a guy named Sunil Yu, who used to be at Bank of America, who, this was 8 years ago, would say, if you don't have an SBOM, I'm taking 10% off your asking price off the top. Not because SBOM was mature enough to use at the time, but because he knew his total cost of ownership from an organization that couldn't even produce it internally was going to be a bad time. So on the question of, hey, is this my secret sauce? It's a fair, and we got a couple of comments on that. First, most of it isn't, right? Let's be honest. No one cares that you use libc. Second, the SBOMs do not have to be public. In fact, today, I don't think many proprietary software vendors are sort of going to have public SBOMs. And third, there is built into both of the popular SBOM formats and the way the US government has described SBOM, the idea of known unknowns, where you can tell the person that you're giving the metadata about your software to, hey, there's stuff in here that I'm not telling you. And I think that's the right way to handle it, where if you say, you know what, there's some math in here, where if you knew we use this library, we'd know how we solve this problem. I get it. That's a completely fair concern. But the solution to that is not to say, we're not going to tell you anything that's in our software. It's going to be very clear. This is, if you think of an SBOM as sort of a dependency tree, you just say, hey, this is the part of the tree that's dark that we're just not going to share.
That's funny because my philosophy, the more we dig into like a lot of these edge devices and, devices in general, the firmware binaries on them, the more we see that the code is just so arcane and is using such old libraries and such vulnerable libraries. My running theory is that they don't really care about the intellectual property. They just don't want to air their dirty laundry in terms of what this thing is actually built out of. It's like a house of sand is what it's actually built out of.
And one, you're not wrong, right? No one wants to have to sort of show what they're doing. And in fact, one of the nice things about SBOM is we can sort of say, hey, it actually tells people what's in there. There are a couple of initiatives and a couple of vendors out there that can actually take an SBOM and give you a metric of technical debt. Hey, I'm about to buy this. I'm customer number 6. So when they have to do their massive refactoring, how much of that is going to be my burden? That's a good question to ask. And that's not a security question, but that's a great risk question that we can build into this data. The other thing, and this is, I think, why the U.S. government has gotten involved and why the administration introduced an SBOM requirement for software that is bought by the United States government, is to say everyone's going to do it at once. And there's one of the greatest economists in the 20th century is a guy named Thomas Schelling. He was actually the advisor to some of my grad school advisors. And he studied hockey helmets. And he noticed that no one in hockey back in the 70s, right? Remember back in the day when a hockey player was identifiable because they didn't have teeth. But no one wanted to be the only person wearing a helmet. Mm-hmm. And that's where the players were actually in favor of the hockey league saying everyone has to wear a helmet because everyone gets the same disadvantage. And now we're all on the same level playing field. And it's the last thing I'll say is it's also, I love it, because it's a great way to reward organizations that have invested in security, that have invested in a modern process, because now their customers can see it. They can get credit for it.
That makes sense. Yeah. But the flip side, the upside, the incentive aspect of it rather than the penalty side.
I think this is where the food analogy may hold up. And because I take issue with companies that are hiding the SBOM and or encrypting or obscuring the firmware or software so you can't look inside of it, right? Because my whole thing is, what are you hiding? Right? It's just like the hacker curiosity in me. I'm like, that means you're hiding something, right? I mean, I've been doing this too long, right? But I liken that to when you pick up a product a food product, and you look on the back, and what if the ingredients said, "Oh, we can't tell you what's in it," and maybe you have a severe allergy, of any kind. Are you gonna consume that product? But yet we do that with technology all the time. Right. Things get dropped off. We purchase things and they're shipped to our doorstep, and we're like, great. It's camera, it's a laptop. Do you know what's inside of it? And if it could hurt you or not? And if the company's not going to tell you, my detector goes off, right?
And Paul, the other thing that's useful about that analogy is what a list of ingredients doesn't do. Because if I have to deal with yet one more person, the SBOM won't solve all of our problems. And they're right. And the SBOM also won't pick up your kids from school if you're running late, right? The list of things SBOM won't do is very long. But that list of ingredients by itself will not protect your family from something that they're having, that they're very allergic to. By itself, it won't keep you on a religious-based diet or your brand new 2024 Best You diet. But you can't do any of those things without the list of ingredients, right? It's the necessary data layer on top of which you can do any kind of intelligence or risk-based behavior that you're focused on.
Right. Yeah, it's what you can do. That's when we get to, and once we have these, then we can do more stuff with the SBOMs, right? We can, well, and that's I think we actually talked about this years ago as well, because when the SBOMs first came out, it was like my first question. I'm like, hold on, I don't trust the software manufacturer. Again, we go back like, I've been doing this too long. I don't know. My level of trust right out of the gate without verification is very low. So out of the gate, I don't trust the software or hardware provider. It's going, hey, here's this thing, and here's the ingredients that I put in it. I'm like, really? Is that the ingredients? So I've always felt like we need a separate process to go, well, I'm also gonna generate my own ingredient list, and then I'm going to compare them. Maybe there's also a third party that has generated a list. And do all these lists match up? Is this one of the activities in your mind, Allan, that is productive for a usage of SBOMs?
So you've got all these different layers, right? I don't know if you've ever seen that. There's a famous Usenix t-shirt that had the 7 layers, and then on top of that was economics, and on top of that was politics. And so when you're thinking about policy, you need to sort of understand what's technically feasible as well as what you're trying to do. So on the trust but verify side of things, I think that's, if you're in a high assurance environment where it is very important that you know exactly what is in a device, then yes, you, and also this is, the correlation also depends on your supply chain, right? If you work with 3 vendors all the time, you have really good relationships with them, and you know everything about their processes and their dev shops, then maybe you can accept their word. Whereas if you have a truly global supply chain and everything is multi-layered, then yeah, you're going to want to say, well, what is the RTOS that's coming on the slow boat over for the thing that has a very important hole in my network? So it's the trade-off of cost, and the security style of what you're looking for. And then, of course, we have the challenge that tools are still being perfected. So are there two different tools may look at a given piece of software and find slightly different things? Is that horrible? Well, there's some great research that I just saw some information about from Pacific Northwest National Labs, PNNL, their Department of Energy research organization. And they said, well, they're building out some tools so that you can compare to SBOMs and ideally combine the data if you need to. So this tool produces this tool produces this, they agree on this, and let me figure out how to deal with the parts that they disagree on. So I think we can make progress on that. And the other thing is that the tools are going to get better. And the last thing is it also depends on where in the ecosystem you're looking for, right? If you're dealing with Golang or modern apps that are written with the 500 most popular projects in NPM, this is pretty easy, right? Your tool should be doing this automatically. If you're in some of the rarer corners, or you're using embedded tools, or you're using some legacy software, legacy languages, then your data is going to be a little more uncertain. But that's okay, because everything in those domains is going to be a little more uncertain.
I feel like the developers in certain pockets, as you pointed out, Allan, can do this SBOM thing. Like, they don't have to really work that hard. I don't want to say work that hard. It's not, because it still is work to maintain a tool chain to develop software, right? But if this is part of your tool chain, I think I've interviewed people from the Linux Foundation. They're like, we make these tools available. We start producing software. I think it's Zephyr was one of the first, at least early, embedded, operating systems. Is it a real-time operating system? Is Zephyr RTOS or not? I don't remember now. Or if it's just firmware.
I should know, but I know it's really, it's this lovely open source operating system, yeah.
But like it gets an SBOM. Like you're just developing for it, and part of your tool chain is built in. The developers are like, oh, I don't have to worry about it anymore. When I write software, when I incorporate a new library, it updates the SBOM, and then what other people do with it is up to them, right? Yeah. Like the developers should be. I mean, other than the proprietary software issue that we talked about already, should be now table stakes. But then you get to smaller individuals, and they have to adopt their tool chains, right? So.
Well, you beg the question too, like, can you be a software house or a firmware house for that matter, and know that you're producing secure firmware by design if you don't have already software
material? It's a great point
to manage vulnerabilities, right?
Yeah.
And we love the fact that SBOM is featured in the NIST Secure Software Development Lifecycle, and to your point, I think so. You know, my background's in tech, but my PhD is actually in applied economics. So I always try to use some of those tools when possible. And there's this concept of an efficient market signal where the signal is, anyone can produce a signal. They can make a claim, but it's cheap if you're doing it right. And it's really hard if you're doing it wrong. And so, right, I can't make an SBOM after the fact, but it's a whole lot cheaper if I just build it into my tool set. And that's where we're sort of trying to nudge people as they're making new stuff. Legacy stuff, different story. But for new stuff, it's a great signal of if someone says, oh, yeah, we can easily produce an SBOM, it tells you that they're more likely to be able to accommodate all the requests that you would want to see about secure software development.
Allan, where are we with making sure the SBOM has integrity, right? And this is something we've talked about, we probably talked about it years ago, right? Since then, I'm like, okay, I'm creating like this list, but how do I know the list hasn't changed somewhere along in the supply chain, right? Where are we with that today?
Fun challenge, and a lot of it depends on, like everything else in security, what's your threat? So are you worried about just mediocre tools? Well, there you can sort of say, well, you can tell people down the stream what tools you're using. You can verify it using, binary analysis tools like we've talked about. If you're worried about someone actually compromising your tool process itself, right? This is the thing that made us all stand up and pay attention with the very publicized attack against SolarWinds. That's where you need to start thinking about what else we can bring to play. So one is, again, doing the trust but verify. Someone paying to use tools, because most of the tools that do binary analysis are proprietary. They're great tools and they're getting better all the time. Where I think we want to head is having secure artifacts along the way. And this is we're seeing this in some of the cloud native world where they're just so far past SBOM. They're like, we don't need SBOM because one, they're using very modern language, very modern tools, and they're using things like there's a Linux Foundation project called Intoto, originally developed by some really smart people at Purdue and NYU, and essentially the vision is at every step of your development and build pipeline, you are generating cryptographically supported artifacts that can say, okay, this action was done on this machine with these keystrokes by this authenticated user at this time. And that's really where I want to get to, is SBOM is just the starting point. It's the easy artifact. Where I think we want to get to for folks who are really concerned about secure development and making sure everything is checked across this pipeline is making sure, okay, let's get every step of the way throughout all the fun things in my Jenkins. In the meantime, what do we have? Well, we've got signing things. And again, nothing's ever simple. Those of you who have bare scars of thinking about PKIs for large organizations know how hard it is. It's one thing to say, I've got a gold CD from Microsoft, but how does that play with a CI/CD pipeline where I've got daily, hourly, minutely builds? Gets trickier. And there are some tools that are starting to track it. Just means generating a lot of artifacts.
Allan, talk to me about Vex. We started talking a little bit about Vex. We haven't really touched too much on like vulnerabilities, right? Directly in this conversation yet. What is Vex for our audience?
So we've talked already about some of the good faith concerns around SBOM. And one of them is that an SBOM may be misleading about what's actually in software. So I can use a component that has a known risk, but I can also use it in such a way that it doesn't actually put anyone else at risk downstream. And so Vex is a way of communicating that efficiently and in a machine readable way. So essentially, one way to think about how it relates to SBOM is an SBOM will turn on a warning dashboard light, which is you're using this thing that could be bad. And Vex allows you to turn off that dashboard light that says someone claims that it's okay. So what is it actually? It's a binding of 3 basic properties: a piece of software, a known risk, a vulnerability today, and then a status, which is, do I care or not? And so being able to say that this piece of software is not affected by a vulnerability is very powerful, right? This is a negative security advisory. And in fact, when we talk to folks like asset owners and critical infrastructure, they want that a lot sooner than they want an SBOM. Because like SBOMs are great, we want them, we'll eventually get them. What we want today is a whole bunch of JSON that easily says everything on our network, do we have to worry about it or not? And then the other piece that's kind of fun in Vex is that it provides further machine readable details to be able to tune your risk. So easiest Vex to issue is just the vulnerable code is not in, the vulnerable component is in my product. So some of us still remember the Log4j lifestyle of trying to figure out where everything was and what was affected. And you know what would have been great is if someone could just write a simple piece of JSON or XML that said, my product's written in C, shut up about Log4j. That would save so much time for the customer support people. Right. And it would save so much time for the people who are actually doing security for their orgs. So that's the easy thing. And then we can slowly work down. Right? So compilers are mysterious, violent things. Right, there are like 7 people in the world who actually understand what compilers do these days. But hopefully we've got some listening. But the vision is, well, if I'm using OpenSSL version old.old, but I'm only using the pseudo random number generator, there's a decent chance that the compiler is going to strip out all the stuff that's related to OpenSSL's web server model, which has the heartbeat function, which created the heartbleed vulnerability. So if the supplier of the software, or indeed anyone else, can go in and verify that the affected code isn't there, that's huge. And again, it's something that we can communicate machine readable, machine writable. And then you get to be a little more nuanced, right? There are claims such as the attacker can't reach this code, or we have inline vulnerabilities. And that sort of gets down to a little trust, right? Do I trust who's saying this? So Vex really is the ability to share scalable vulnerability information in a machine readable way.
Now, Allan,
and I'll just finish one of the. Oh, good. Yeah.
I was just going to say, if I were to contextualize this and spit it back out to give advice to people, right? Not that you should take my advice, but it's free, so I'm going to give it to you anyway. You should use things like Vex and Vex itself to identify if it's something you need to pay attention to right now, or something you need to just, worry about as part of your normal operational planning. I think what it's good at is there's something really bad that you have to pay attention to and you should address now, right? And everyone's going to differ slightly on maybe what those are, but I think there are classes of things. When I looked at the QuickSec example in Zixel firewalls, that was a 1-packet remote code execution, no authentication required, and I believe gave you root privileges. So if Vex can help us go, you've got that component in your stuff, I'm like, okay, that's good. The other stuff, it kind of concerns me because I've analyzed our industry and vulnerabilities for over 18 years on the show and longer than that, right? And I've seen the track record where we go, yeah, this isn't so bad because of X, Y, Z, but then things change. Someone comes along later and goes, no, this is like really exploitable, right? And what I don't want people to do is go, I don't have to address those things. I don't think that's what Alan's saying either, right? You do have to address those things, but you have to address them like in an appropriate manner and just not forget about them completely, because someone's going to come along and go, oh yeah, like null pointer dereference and integer overflows. Like there were times when we thought those were either really hard or impossible to exploit, and then security reachers come around and they make that table stakes. So you still have to update all your stuff.
And with you completely. And part of it is about claims, right? Who do you trust, and when was it claimed? There's always someone who's going to be able to chain different vulns together. So things that no one could really pop with today, in the future we'll be able to. But I also think that we should not just say this vulnerability is here, everyone panic. Let's focus on what needs to be updated. So in a hardware context, for example, there are going to, what is the vulnerability that I'm just truly amazed that we made realistic in my lifetime is Rowhammer. Right, where just you can do a little bit of rewriting back and forth and actually flip bits next to the data that you cared about. But what we can do today is now go to the people who are not just making the silicon, but making the environments where the silicon is running to say, okay, yes, in this context, the Rowhammer attack doesn't make sense. So you don't have to worry about it for this line of products, but you probably do for this, right? You don't need it for your blade, but you do need it for your laptop and vice versa. And that's where I think we can sort of make some progress on prioritization. And the other area that I like about Vex, and I've talked about this with some of the vendors in the bug bounty space, is, hey, if I'm going to make a claim that says that this product is not affected by a vulnerability, and it's specific, right? Not that no one can attack it, but that this vulnerability does not affect this product, then I can put some money where my mouth is and say, hey, if someone can prove me wrong, here's a formal bounty that we can go for it. So I really like that model of sort of moving this direction.
I like that too, because the bounty programs make sure that it's responsible. Well, they do everything they can to make sure it's responsibly disclosed, that all parties are happy, set expectations for everyone, and publicly communicate, right, as part of that process. And again, bug bounties aren't perfect. People love to harp on the 1% of bug bounty stuff that goes wrong and not talk about the 99% that happens all the time that is fabulous for all parties involved, right? So, yeah.
I think I'm inferring from this that the Vex standard requires somebody to identify themselves, some party or organization, as having verified that the vulnerability doesn't affect the thing. Is that true?
It's intentionally designed to allow anyone to issue a claim. So, right, you can imagine a security researcher, one of the great research outfits or stables to do this. But we also think that the most common is going to be the product security. It's going to be the vendor itself. And then who you listen to and trust, that's something that we are punting on. So, and I will say that product security teams got very nervous when we said anyone can issue a Vex, because they said, well, how will people know what to trust? And I think data isn't free floating. You get it from someplace, and often you pay other people to curate your data for you. And that's true for threat intelligence, right? Anyone can produce threat intelligence. Who do you trust? And this all is a function of how much time and how important is the data to be actually accurate and trustworthy. So we have a world where anyone can issue a Vex. We think that the first people that are going to be really excited about it are, in fact, we know it already is happening from the product security teams. So folks like Siemens, Red Hat are already issuing Vexes today.
But there does a John Hancock, like an identity, go into the Vex record? I'm thinking about like after the fact, right? So like you issue a Vex and this thing's not vulnerable. A bad day comes along, a worm hits, and a bunch of people are upset. do they go back to that VEX and say, hey, this person or this organization said that? And does that include like legal aspects after the fact? Or could it include legal, accountability?
I certainly cannot talk about the legal side of the accountability. I've spent time in my former life as a professor thinking about software liability and what that means. Today, my interest is just saying, how do we enable communication and promote communication? And to answer your immediate question, yes, there is some information about who is issuing that VEX. And ideally, it will be tied to a key so that we can, some cryptographic support for it. But again, it's also, right, if you trusted something, you probably saved a copy of it somewhere so you can at least figure out, okay, what did it say originally? Is that helpful?
Yes, I'm just a huge fan of accountability at this stage, especially with these vendors. Right. Like we spend a lot of time on the hardware side, but it applies to software as well. You look at the executive order and you're like, attestation, I got it, but that's a trust and hope we verify someday. Like, where is the audit function? Where is the accountability? Where is the enforcement aspect of that and that maturity life cycle of that executive order? Like as it carries out, I want to see those things come into play so we can actually affect change instead of just having a security theater every 10 years.
And I'm with you completely. And then the missing piece there is, right, the incentives. So a good VEX ecosystem will both help customers and suppliers. It helps customers because they say, I don't have to patch the things that aren't important. Helps suppliers because they get a much cheaper customer support experience, right? People aren't always calling them up saying, hey, is this, do I have to worry about eternal blue for this thing? And so, but there is going to be some lifetime trust model where we say, hey, you know what? This product security team is great. This other product security team, they're trying their hardest, and we still kind of trust them, even if we move a little more slowly on their activity. And this one just got bought by private equity, and they fired all their security, so we're just not going to believe anything they say. So at a certain point, you have to look at the messenger, and VEX does give you that messenger to sort of figure out what to trust. And it's the same thing is true for other types of security advisories as well.
I like it. I like everything you just said, 100%.
Allan, one thing that really grinds my gears is end of life and end of support products, right? That as we've already established very early in this podcast, right, segment, that software changes, right? Until it doesn't change, until the vendor, the creator goes, yeah, we're not supporting it anymore. But now if it's not changing, any obviously new, mostly vulnerabilities. I mean, if they're not pushing out anything new, it's kind of hard to backdoor something that's not being produced, which is kind of interesting. I never thought about it that way. I'm thinking out loud. But certainly new vulnerabilities, right, don't get fixed. How do we do that? Is there an indication in the SBOM that like, hey, this was the last one? Right? Have you thought about this process for end of life, end of support?
So, happy coincidence. This is something that we're working on at CISA, just starting this discussion because, ironically enough, end of life and end of support are things that we collectively haven't made a lot of progress on. There are a couple of fun websites that are out there that are trying to collect this data themselves, but there isn't really a national vulnerability database to look things up. We can sort of say, hey, let's not replicate the NVD, given some of the real and valid concerns that we have with the NVD today, but very least we need to start moving this direction. We need to, one, come up with some better definitions. There aren't really robust global definitions, and the ones that are there don't necessarily apply to every sector, right? End of life means something very different for the telecommunications industry, where or industrial control system, 20-year lifetimes, versus consumer IoT versus just your left pads of the world. And then second, the difference between proprietary versus open source. Right? Open source software is given to you as is. What does it mean to say that it is no longer supported? And how do we sort of make sure that without compelling any one project to do anything specific, we can still say, here's some meaningful statements that a project can share so that everyone around it knows what they can expect. And of course, right, this is where you have commercial open source versus just standard or more broad open source. That's the difference in support. So we're trying to make some progress on that. We'll hopefully have something fun to say over the next few months, explicitly starting the ball rolling on this idea of how do we make sure this is integrated into our risks. And there's a reason why this work landed in the SBOM team. It's part of the national cybersecurity strategy. But right, it's so built into how we think about supply chain that we want to make sure it aligns to it. And I like your idea of saying, is there something that we can think about as an SBOM model, or at very least make sure that if I have an SBOM, I can map to some other source of ground truth to figure out whether something's still supported.
Yeah, like it's interesting. Now I'm going back to the food analogy that I'm not like 100% on board with, because I don't think it's 100%. No analogy is 100%, but there's an expiration date on it. And that's, when you buy food, that's communicated to you in the package labeling almost as part of the ingredients list or SBOM to say there's an expiration date. Now, to say that every software hardware vendor knows once they ship a project exactly when the expiration date is for that, probably not. So it probably needs to be some dynamic mechanism that could be tracked, maybe perhaps in an SBOM, or at least indicate once it is end of life that, hey, you're reading this SBOM, and by the way, none of this software is going to change.
So this question is always astoundingly controversial. So I did some work on IoT field upgradability back in 2016, 2017. And one of the things that, 2018, but try to come up with a small set of things to describe and the mechanics of patching and how do you make sure patching is secure? Because, by the way, a security update that isn't secure is called RCE, right? So we need to make sure that we have that side of things as well. But the thing that industry really pushed back on was committing to how long they were going to support given types of devices. And I sort of get where they're coming from, right? If I make a brand new refrigerator, I don't know if I'm going to sell 1 million or 7 of them.
Right.
And that I may not want to support those 7 fridges. There are other sectors where we don't allow you to do that, sort of be so flippant, right? Automotive safety, there are pretty clear rules. And so thinking about what that looks like from a regulatory perspective is complex. A lot of fun discussion that's happened. Those of your listeners who are in Europe are probably aware that there's some interesting discussion on this in the Cyber Resilience Act. So this is something that, 1, we need to better understand, and 2, we need to harmonize as we build rules.
So where I want to go next. Well, I don't know if this relates to SALSA. SALSA is more about preventing tampering, right? I guess where I wanted to go, Allan, was talking, kind of going back to vulnerabilities in my experiences looking inside, let's just say firmware, right? And one of the things that we do and automated tools do is they look at all the software that's inside of your firmware and they go, these versions are really, really old. If we started doing this for all the firmware that exists in the world today, I think we'd find many commonalities and we find that it's really old. Now, I don't want to, like, how we measure that and then determine some kind of risk-based score, how it impacts a risk-based score. It is not just a cut and dry thing of going, well, you've got 20 old packages and you've got 30, so therefore you're more vulnerable. That's not, you can't. That's not apples to apples. That's not even comparing fruit, right? So, like, how do we bring this to light, and how do we use it as a measurement? The fact that there's really old software in a lot of this firmware.
And it is, by the way, it's also really funny. When both of us started our careers, the idea of really old software wasn't quite as much of a thing.
Right.
And now, right, there's just, we've got a lot of accrual. We haven't gotten rid of the older stuff. This is one of those moments where I certainly don't want to speak out of turn because there isn't just a technical side, there's a policy side of things. There are some fun metrics that I've seen or companies that are offering some risk scoring tools. I think the general rule of thumb on those is the more precise and field specific you are, the more you can trust them. Someone who can say, I can do a web score, a security risk score for a web app and for, legacy embedded in the same tool.
Yeah.
We should be a little suspicious of that. But I think there's some fun efforts that are going on now. So Linux Foundation has the security scorecard for modern open source packages where they just say, hey, here are about 17 things, 19 things. Apologies to my Linux Foundation friends for not remembering the exact number, where you can sort of look at to say, okay, you may not need all of them, but it gives us some idea of the health of a project to know whether we should include it moving forward. Looking backwards gets tricky, but we're starting to get some better sense of what that looks like and also how they're put together. And this is where you also need your holistic analysis, whereas, okay, is this device meant to be general purpose, or is it meant to do a very specific thing, which I can sort of layer over some controls on its executive function as well, rather than just sort of having to accommodate any given control or any given attack model because I can do anything on the system. So there's some models there. I wish I had a better answer. I don't know. What have you seen, Paul?
It's interesting. I'm not sure the right metric, but I think there needs to be part of a score that goes, you've got like this much older software, how old that software is, right? Any known vulnerabilities, kind of calculate that and go, like, it should negatively impact the risk score, right? You should be that's more risky. I think where a lot of the math comes in is like comparing that to other firms, because no two software packages are the same, but it should be included in that metric, like how much older software, because to me it's indicative of how well maintained that software is, right? And how much they're trying to keep pace with those things. I also think the scenario that's really interesting is tying an SBOM to the version, right? Because you got older, let's say you got an older version of a package in some kind of firmware or software package, right? And then you go, well, there was a vulnerability there, so this version 2 it's fixed, but all we did was remove that software from the previous version. Well, you still need to have an SBOM tied to that previous version because you didn't actually like patch it. You just removed it it means everyone's got to upgrade, right? And if you still run the older one, you're going to be vulnerable until you upgrade.
And this gets back to two things we were talking about at the top of the show. One of them is just versioning, which is, hey, if you change your software, you need to change your SBOM. Right. And that gets tied into your asset management or the things of that ultimately as an organization, I need to know what's on my network. And it also sort of talks about some of the pieces in the legacy side of things, whereas, okay, is this very stable, and what kind of change do I want? Backporting, which we talked about at the top of the show, really messes with my data, right? I think, in a pure form, if you fork it, you own it, right? If I just go in and tweak one line in OpenSSL, well, now I've created Allan SSL. And I need to not only track that, but I need to remember that Allan SSL is a fork of this exact version, so that when there are flaws found there, I can go fix this. This gets very messy very quickly, but we are starting to be able to capture that information in an SBOM. And so that's another fun area where we've seen some good work is both of the SBOM data formats today can sort of accommodate the idea that this piece of software came from this piece of software.
Yeah, because once you start backporting, it's your software. Every Linux distribution has its own software, because once you backport that first fix, now you've got to basically backport and update in a different fork from where the software was originally. Essentially, it's different software at that point in my mind.
Yeah. Yeah. But on the other hand, coming down from on high saying that no one should backport anymore is just one of those things.
We can't say that.
Even if it's good engineering.
Right.
Yeah.
It does, because it has its place. From the flip side of it, I totally get it. Right? Do I need to regression test the whole thing, or just can I backport this one thing? I get it. Yeah. Scott, did you have more questions for Allan? Sorry.
I just have one. It's a little open-ended, but if I step back and I ask myself this question these days, as everybody is, where are some ways that you might be aware of, or that you're working with, that where you're applying LLMs and ML to solve for some of these sticky challenges that we're talking through as humans? Like, this whole conversation has been a very human industry, and you mentioned politics and all the other economic drivers associated with this problem. But is there an ML LLM side that we're seeing some progress, or that might give us some hope, or some things that we should check out that you're aware of?
Sure. So, one of the DC sports metaphors I like is Pee Wee soccer. I love watching little kids play soccer because they all sort of glom onto the ball wherever it goes. That's generative AI right now. But there's some really cool stuff happening. So one, we've talked a lot about machine readability, right? The importance of saying, I don't want to do security myself. I want my systems to handle it. And one of the nice things is LLMs in particular seem very good at taking more general data and turning into things that we can just slot into a JSON input. And I haven't seen good analysis for specific applications to see what the error rate of that is. And, one of the big questions that we talk about at the policy level is what level of error is acceptable given a given context. So that's one area of just sort of starting to do some of that matching. Even well before we had the generative AI world, we talked earlier about software identity and the idea of being able to look at, okay, I've got my firmware analysis tells me that there's a little bit in here. What's that actually called? Is it the same as this thing over here? That's an area where, machine learning has been helpful and is getting better all the time, especially when we get better and better databases. And then the last piece, there's a ton of great discussion happening on using generative AI to better identify vulnerabilities as we code and things like that. But the last piece that has touched my world on transparency is to say, well, how do I know what's in the LLM itself? And what does SBOM for large models and generative models look like? We don't know yet. And what's interesting is I'm seeing that conversation happening in two separate areas. They're the folks who get software development and security, but aren't AI experts. And by the way, I'm in the bucket of not being an AI expert, that are talking about transparency. And then you have the AI people that are talking about the AI side of things, but may not understand the security side and the policy side of thinking about transparency. And so moving forward, we're going to be paying a lot of attention to where those conversations are happening and how we can make sure that both of those communities are represented in the discussion. Go ahead.
Well, I mean, that for me, the thing I would tack onto that almost, not as a corollary, but AI is a software package where you're actually, doing the AI at a software level, but underneath there's the entire platform and supply chain to the processor, the memory, the CPU, the cloud infrastructure, the networking, the crypto system, if there's one protecting it, et cetera. And I think where we will easily fall down with AI is if we don't readily address the platform that protects the integrity and verifies, then trusts every transaction at that hardware level. And you already saw that with like the NVIDIA DGX vulnerabilities, where you have these, massive 8-core CPUs dedicated to AI that they're exposed to the internet as BMCs. And like, are you serious, right? Because data integrity kind of matters when you're doing AI things, right? So I think that's one of the things that we should really try to fold in at the policy level as soon as possible, before it's too late.
Fantastic. And I'm with you that, and in fact, this is the official CISA position, a blog post written by two amazing colleagues of mine, Christine Lai and Jonathan Spring, that basically said software should be secure by design. And by the way, AI is software. And so everything that we have learned about secure development, secure operation, we really need to make sure is part of the AI world. And I'm not above making fun of Python developers and how bad some of the data science written code is. So we really need to sort of help that community understand secure development and the full stack.
Allan, sorry, we're running short on time, but I want to thank you for appearing on Below the Surface. It was fun chatting with you as always.
Always happy to hang out. Thanks.
Thank you, Scott, and thank you everyone for listening and watching this edition of Below the Surface. We'll see you next time.